Okay, so blockchain, right. It's like changing everything we thought we knew about, well, everything. But have you ever actually stopped to think about how a transaction, how it actually gets added to that super secure blockchain ledger? I mean, it's not like sending a regular old email, is it?
Not even close. It's way more complex than that.
Right. So today, we're going deep. We're going to break it all down.
Yeah, we'll use that source you sent in, the PDF. How is a transaction verified on a cryptocurrency network?
Oh, perfect title. That's exactly what we're doing. So think of it like this.
Okay.
Like you're sending, I don't know, a super important package, like something you really don't want to get lost or messed with.
You wouldn't just trust it to anybody, would you?
Exactly. And in the crypto world, that package is your transaction. And we're going to track its journey.
From the moment it leaves your hands all the way to its final destination.
The blockchain. So first things first, right? We're sending some cryptocurrency. You create the transaction.
Yeah.
But then you got to sign it.
Ah, yes.
With your private key. And that's key, so to speak.
It really is. The private key is like your unique digital fingerprint.
So no one else can forge it. It's like a super secure stamp that says, hey, this came from me.
Exactly. And that's what proves the transaction is authentic. And that signed transaction, it gets broadcasted out.
Out to the network, right, for everyone to see.
Not just everyone. Well, sort of. Think of it like a city, a bustling city full of inspectors.
Okay, I'm picturing it.
All right, good. Each of these inspectors, these are the nodes, and they're all meticulously checking every single transaction.
Thorough. But what exactly are they looking for?
3 main things. First, they verify your digital signature. They got to make sure it matches up.
With your public key, so it's like a double check that it's really you.
Right. Then, they got to make sure you actually have enough funds. No overdrafting allowed in crypto land.
Makes sense.
And finally, they look for any funny business.
Funny business.
They're like, has this transaction been used somewhere else? Have you tried to spend the same coins twice?
Trying to pull a fast one.
Exactly. We call that double spending, and the nodes are on high alert for it. They stop it in its tracks.
So it's like a triple check system. That's pretty reassuring, actually. But what if a transaction fails one of those tests? What happens then?
It's rejected. Simple as that. It's like the package gets returned to sender.
Address unknown. Return to sender.
Exactly. Only the valid transactions, the ones that pass all the checks, those are the ones that move on to the next phase.
Okay, so now we've got a whole stack of transactions that have passed inspection.
Yeah.
They're all good to go. But now the network has to decide.
Decide what?
Which transactions make the cut, the final cut. And that's where these consensus mechanisms come in. I know the source mentioned 2 of them.
Right. We've got proof of work and proof of stake.
Proof of work, that one sounds intense. Yeah. Like really intense.
It kind of is. Imagine a competition.
A competition?
Yeah, like a massive global competition.
Between who?
These specialized computers called miners, and they're all racing to solve these super complex math problems.
Wait, so it's like a math-solving marathon?
Pretty much. And the winner gets to add a new block of transactions to the blockchain. Like they've earned the right to deliver the package.
A digital treasure hunt. But I've heard that this proof of work, it can use a lot of energy, like a crazy amount. Is that true?
Yeah, that's one of the big drawbacks. It takes a huge amount of computing power to solve those math problems. And all that computing power, it means a ton of energy. We're talking massive server farms running 24/7.
Okay, so not exactly eco-friendly. So what about this other method? Proof of stake? Is that the more eco-friendly option?
Well, in a way, yeah. Instead of this huge energy-guzzling race, proof of stake is more about, imagine putting down a deposit to vouch for the package.
A deposit, okay.
Right, so in this case, validators, they stake their own cryptocurrency. They essentially lock it up as collateral.
So the more they stake, the more likely they are to be chosen to validate transactions.
Exactly. It's like saying, I trust this transaction so much, I'm putting my own money on the line.
Interesting. So it's less about raw computing power and more about, having skin in the game. But couldn't that lead to problems? Like, what if a small group of people who have a ton of cryptocurrency end up controlling everything?
That's a great question. It is a concern, yeah. It's one of the big debates around proof of stake, for sure.
Right, because it kind of goes against the whole idea of decentralization, doesn't it?
Yeah, you could say that. If a small group ends up controlling most of the stake, it could become, centralized. But, developers are always working on it, trying to find that balance,
Yeah, finding that sweet spot. So it's energy efficient, but also keeps things fair.
Exactly.
It makes you think,
Yeah.
Like if you were designing a system from scratch, what would you prioritize?
Right. What would be your top priorities?
That's a tough question. But let's get back to our transaction. Okay. So whether it's been validated through like a massive math competition or by staking their crypto, what happens next?
So now, all those transactions that have been verified, they all get bundled together.
Bundled together?
Yeah, into a block. It's like you're putting all the proof packages into a container.
Okay, so we've got this container full of transactions all ready to go. But how do we know, how do we make sure that nobody messes with it along the way? Like changes something or tries to tamper with it?
That's where the chain part of blockchain really comes into play. See, each block, that container of transactions, it's linked to the one before it.
Okay.
Using something called a cryptographic hash. It's like a super secure seal.
A seal?
Yeah. If anyone tries to change even a tiny bit of information in a block, the hash changes completely. It's like immediately obvious that someone's been tampering.
Wait, so it's like a chain of evidence, basically.
Yeah.
You mess with one link and the whole thing falls apart.
Exactly. That's what makes the blockchain so incredibly secure. It's practically tamper-proof. And once a transaction is added to the blockchain, it's pretty much set in stone.
Wow, that's pretty cool. It's like this permanent, unchangeable record.
Exactly.
The immutability of the blockchain. But it also makes me wonder, what if, like, the network suddenly gets flooded with transactions? Can it handle that?
Ah, you're hitting on a big one there. Scalability. That's one of the major challenges facing cryptocurrency right now.
Right, because, like, Visa processes thousands of transactions every second, right?
Yeah, they do. And current blockchain networks, especially the ones using proof of work, they're just not that fast.
It's like trying to fit a whole city's worth of traffic onto a single lane road.
Perfect analogy. Total gridlock.
Right. So what are people doing about that?
Well, developers are working on all sorts of solutions. One of the big ones is layer 2 solutions. It's kind of like creating express lanes,
Oh, okay. So it takes some of the transactions off the main blockchain.
Exactly. So it can handle the load better.
Makes sense.
Yeah.
But what about that energy consumption problem we talked about? Especially with proof of work, it's a big concern, right?
Oh, for sure. The amount of electricity used to mine Bitcoin, for instance, it has a real environmental impact.
Yeah, and it's not just the electricity itself. It's also, like, manufacturing all that specialized mining hardware, right? And then what happens to it when it's obsolete?
Exactly. It's a whole life cycle impact. And that's a big plus for proof of stake, It uses way less energy.
Right. No need for all that intensive mining. So potentially a more sustainable option.
Right.
But even with all these security measures, all these checks and balances, are cryptocurrency networks truly impenetrable? Like, what about hackers? Can they get in?
Well, the blockchain itself, it's incredibly secure. Tampering with that chain of blocks is, it's practically impossible.
But there are other vulnerabilities.
Right. Outside of the blockchain itself.
Like what?
Like exchanges getting hacked. You hear about that sometimes. Or people falling for scams, like phishing scams. And even vulnerabilities in the code of smart contracts.
Wait, what are smart contracts?
Oh, they're like self-executing agreements on the blockchain. But sometimes there are flaws in the code. And those flaws, hackers can exploit them.
So it's like you have this fortress,
Sure.
right? With steel walls and everything, but someone left the back door open.
That's a good way to put it.
So security is like a multi-layered challenge.
For sure. It's a constant back and forth. Developers are always trying to stay one step ahead of the bad guys.
Okay, so we've talked about scalability, energy consumption, and security risks. These are some pretty big challenges. But I'm also pretty impressed by all the people working on solutions,
Oh, yeah, absolutely. It's a really exciting field. It attracts some of the brightest minds out there, people who are really passionate about pushing the boundaries of technology and finance.
It's inspiring. So what do you think, what does the future hold for all this? For cryptocurrency transaction verification? Any predictions?
Well, if I could predict the future, I'd be a very rich man. But what I can say is that the pace of innovation is incredible. Like, we've talked about proof of work and proof of stake, but there are others emerging too, right? Like proof of capacity.
Proof of capacity? What's that?
It uses your unused hard drive space to validate transactions.
What? How does that even work?
Basically, it leverages the empty space you have on your hard drive to store data, and then that storage capacity is used to vouch for transactions.
Wow. That's so clever, like repurposing something that's already there.
Yeah.
And then there's all this buzz about zero knowledge proofs, right?
Yeah, that's a hot topic right now. That technology, it could change everything. It has the potential to make blockchains way more private and more scalable.
Maybe that'll be our next deep dive, huh?
I'm in.
Okay, so to our listener, I think we've covered a lot of ground today. We've gone from Like a single transaction all the way to the future of the whole system. It's been quite a journey. But before we wrap things up, I want to make sure you walk away with a few key things. Because, I mean, we've been talking about this stuff for a while now.
Yeah.
And it can be a lot to take in. So key takeaways, right?
All right. Number one, understanding how transactions are verified, it's essential. Like, if you want to engage with cryptocurrency, you need to know this stuff. It's not magic, it's a process. And that process is what ensures trust and security.
Yeah, it's about demystifying the whole thing, right? So people can feel confident.
For sure. And another thing, you got to be aware of the challenges, like scalability, the energy use, the security risks. Those are real issues.
Yeah. It's not perfect, not by a long shot, but it's exciting to see how it's evolving, you know?
I agree. And lastly, cryptocurrency. It's still early days.
Right. It's like the Wild West out there.
Exactly. So much potential, so much room for innovation. And knowing what you know now, I mean, it's a really thrilling space to watch.
Absolutely. It's been quite a journey today, from, you know, that single transaction to like the big picture, the whole future of this system.
I know, right?
But before we sign off, before we say goodbye, I want to leave you with one thought, one last thought to ponder.
Me too. You know, we've covered the tech, the challenges, all the potential, but at the end of the day, cryptocurrency. It's about more than just the code, the algorithms, all that stuff.
Right. It's about like a shift in how we think.
Right.
About money, about finance, the whole system, really.
Yeah. It's about challenging the status quo, looking for new ways to do things, transacting, creating value, participating in the global economy. It's all changing.
And I think it's about making informed decisions, like what kind of financial future do you want to be a part of?
That's the question, isn't it?
And that's why it's so important to keep learning. Keep asking questions. Keep digging.
This world, the crypto world, it's constantly changing. There's always something new to learn.
Exactly. So, listener, keep diving deep. Keep exploring. There's a whole universe out there waiting to be discovered. And until next time, happy exploring.